Hello everyone, welcome to the world of physics, and today we are going to solve the MCQs of chapter number 1. Our chapter number 1 is electric charge and field. So let us solve the MCQ number 1. When air is replaced by the dielectric medium of constant K, the maximum force of attraction between the two charges separated by distance d is what? The force acting in a medium is 1 by K times the force acting in a air. So for air is replaced by the medium of dielectric constant K, then the force between two charges separated by distance d becomes K power minus 1 times. So answer is B, K power minus 1 times. Question number 5 is same as this question. If the force F is the force between the 2 point charges submerged in a medium of dielectric constant K. So here Fm is equal to F is given. Then on withdrawing the medium, if you withdraw this medium, then it becomes air. The medium between two charges becomes air. The force between the charges the force in a medium becomes what? The force in a medium is equal to force in a air divided by K. So force in air is equal to Fm into K, and Fm is given F. So force in air becomes F into K. So your answer is B, right? So मीडियम के अंदर फोर्स कितना होता है? एयर के अंदर फोर्स डिवाइड बाई K. सो अगर मीडियम के अंदर फोर्स F दिया है तो एयर के अंदर फोर्स कितना होगा? F into K. So these both questions are similar type. Question number 2. The question is related to electric field of dipole. An electric dipole coincide on z-axis. Its midpoint is on origin of the coordinate system. So dipole is on z-axis, then its center is on origin. The electric field at an axial point at a distance z from the origin is Ez. The electric field at an axial point is given by 2kpr divided by r square minus a square whole square p cap, and the field on axial equatorial point is kp divided by r square plus a square power 3 by 2 minus p cap. So on the axis the electric field is given by Ez. So Ez is equal to what? And here it is given z equal to y equal to a. So both distance are same on equatorial point and on axis. Read the question further. And electric field at equatorial point is at a distance y from the origin is Ey. So on axis electric field is Ez, and on equatorial plane electric field is Ey. So for a distance greater than a, this formula becomes 2kp divided by r cube p cap, and this formula becomes kp divided by r cube minus p cap. And here the distance is given z, so 2kp by z cube is the electric field on the axial point, and the kp by y cube is the electric field on the equatorial point. Then what is the ratio of Ez and Ey? So magnitude of Ez divided by magnitude of Ey is equal to 2kp by z cube and kp by y cube. So we are dividing magnitude only, so ignore this p cap and minus p cap. This is the direction of electric field. So kp cancel, and y and z also similar, so y cube and z cube also cancel. So answer is 2. So B is the answer. The fourth question is also from this topic. The relation between the intensity of electric field of a dielectric dipole at a distance r from its center on its axis and the distance r is. Relation between electric field and distance is what? For r is very much greater than 2a. For r is very much greater than 2a, the electric field is inversely proportional to r cube for dipole for both the case. So remember this note. For single charge, the electric field is inversely proportional to r square, and for dipole, the electric field is inversely proportional to r cube. And similar, for single charge, potential is proportional to 1 by r, and for electric dipole, electric potential is inversely proportional to r square. This is the most important note for MCQ. Let's solve the question number 3. A circle of radius A has charge density lambda. One circle is there and its charge density means charge per unit length is lambda cos square theta on its circumference. What will be the total charge on the circle? Here on circle the charge density is varying with the angle theta. So the different charges are present at different places. So divide this circle in a small arc of length dl. That arc is of angle d theta and it is at the angle theta from the x-axis. So the charge present on this arc is equal to charge on unit length is lambda, and what is the charge on dl length? Lambda into dl. Arc length is equal to what? Angle into radius. Here radius is given a, so a d theta is the length of this arc. So lambda is equal to lambda 0 cos square theta a d theta is the charge on this arc. The total charge on the circle is equal to integration of all these charges. So integration a lambda 0 cos square theta d theta. Now for the total charge, the first arc is present here, so it makes an angle 0 with the x-axis, and last arc is present here. This makes an angle 2 pi with the positive x-axis. So in limit of theta is what? 0 to 2 pi. A lambda 0 is constant. What is the integration of cos theta? To integrate cos theta, use the formula cos square theta is equal to 1 plus cos 2 theta by 2. So this is equal to integration of 1 by 2 and integration of cos 2 theta by 2. The 1 by 2 is constant and integration of d theta, 1 by 2 d theta means 1 by 2 is constant and integration of d theta is what? Theta, 0 to 2 pi. And the integration of cos 2 theta for full cycle is equal to always 0. So answer is a lambda 0 1 by 2 2 pi minus 0. So 2 cancel. A pi lambda 0 is the total charge on the circle. Pi a lambda 0. A is the answer. Question number 6. It is from the behavior of dipole in electric field, external electric field. So first revise this topic, behavior of dipole in electric field. In uniform electric field, and in non-uniform electric field. If the electric field is uniform, then the resultant force acting on dipole is always 0 and the resultant torque acting on dipole is P cross E. So the magnitude of torque is P sin theta. So when theta is equal to 0 or pi, the torque becomes 0. So in uniform electric field, the force is always 0 and torque may be 0. Force acting on dipole is always 0 and torque may be 0. Whenever the angle between P and E is 0 or pi degree, then it becomes 0. Torque acting on dipole becomes 0. So behavior of dipole in non-uniform electric field is force acting on dipole is always non-zero. Always non-zero. And torque acting on dipole is also similar as uniform electric field P cross E. So that is also may be 0. May be 0. So the sixth question is, if the dipole is placed in non-uniform electric field, then resultant force on dipole is 0. Resultant force on dipole may be 0. Torque on dipole may be 0. Torque on dipole is 0. Torque on dipole may be 0 is our answer. Next question. Question number 7. The charge equivalent to 6 into 10 power 18 electron is, charge on any particle is Q is equal to Ne, and number of electron is 10 power 18 and charge of electron is 1.6 into 10 power minus 19. So 9.6 into 10 power minus 1, so 0.96. This is approximately 1 coulomb. So remember that whenever you are removing electron from any body, then it becomes positively charged, and the total charge is equal to number of removed electron into charge of electron. And whenever you are adding electron to any body, then it becomes negatively charged, and the charge on the body is becomes N into E, number of electron added into charge of electron. Remember this concept. And the charge of electron is negative, so here also charge is negative, minus 1 coulomb. Charge is minus 1 coulomb. 8th question. To know the presence of charge on the substance, the electroscope is the device is used to check the presence of charge on any substance. So electroscope is answer. 9th. As shown in figure, the 4 electric charges are placed on the vertices of a square and there is a free electron on it. Where this free electron will move? Here alpha is present, here beta minus is present, proton is present and alpha is present. Alpha means 2He4, so charge of alpha is plus 2E, so plus 2E charge is present here and here also. Charge of beta is minus E and charge of proton is plus E, so this much charges are present at the corner of this square. What is the free electron, where this free electron will move? So find the direction of electric field at this point. Electric field due to plus charge is in outward direction, so it is in this direction, going outward from this charge. Electric field due to discharge is also outward direction, it is in outward from this charge, so it is in this direction. Both electric field are in opposite direction and both having same magnitude, because the charge value is same for these two charges and distance is also same for these two charges. So resultant of E1 and plus E2 is also 0. Now charge electric field due to plus E charge is going outward from this charge, that is in this direction, and due to minus charge is inward in from this point, so inward from point to this charge, it is in this direction. So resultant field is in this direction. The force acting on charge in electric field is Q into E. The force acting on negative charge is in the opposite direction of electric field. Opposite direction of electric field, and force acting on positive charge is in the direction of electric field. So this is the electron. So force acting on negative charge is in the opposite direction of electric field. So it is in this direction. Electric field is in this direction, so the force is in this direction. So resultant force act in this direction. So it will move towards D. It will move towards D is the answer. 10th question. Two spheres carrying Q charge are hanging from the same point of suspension with the help of thread of length 1 meter. In a space free from gravity, the distance between them will be. Whenever you hang the two spheres of equal charges with thread, then what happen? This both will repel each other. Both are having same charge, plus plus or minus minus. So whenever the gravity is not present, these charges are moved and arranged like this. So this thread is of 1 meter length and this thread is of also 1 meter length. The distance between two spheres becomes 2 meter. Whenever the gravity present, then what happen? The another force mg is also act on this gravitational force. So these two spheres are at a distance 2 theta from each other, or you can say that the linear distance r, they are placed at linear distance r from each other in this equilibrium condition. In this equilibrium condition, the forces acting on these spheres are mg, the force in a thread is tension, and the repulsive force due to this sphere q charge will apply repulsive force on this q. So this will take away from this sphere, will take this sphere away from this. So this becomes k q q, q square by distance between them is r square. So convert this tension force into components. If this angle is 2 theta between two spheres and this half angle becomes theta. So this is theta, then this angle is also theta. So this component is t cos theta and this component is t sin theta. In the equilibrium condition, t sin theta is equal to k q square by r square and t cos theta is equal to mg. Now you can divide this both equation and you will get tan theta is equal to k q square by r square mg. From this concept you can solve any question. So remember, whenever the gravity is not present, the angle between them becomes 180. Whenever the gravity is present, then it becomes some angle theta, 2 theta, the double of this theta, and you can calculate this theta from this equation, right? So remember both this concept, in the presence of gravity and in the absence of gravity. So our question, the space free from gravity, so the distance between them becomes 2 meter. 3 identical charges placed on the 3 vertices of a square. 3 charges are present, q, q1, q2 and q3. The force acting between 1 and 2, suppose the length of length of side is L and the distance between q1 q2 is L, then the force acting between 1 and 2 is k q1 q2 divided by L square, and the distance between 1 and 3 is equal to root L square plus L square, so 2L square, so it becomes root 2L. So force acting between 1 and 3, q1 and q3 is k q1 q3 divided by 2L square. Root 2L whole square means 2L square. Then what is the ratio of them? F12 by F13 is equal to what? K q1 q2 by L square divided by k q1 q3 by 2L square. So k q1 q3 cancel, L square also cancel. So 1 by 2, denominator of denominator go into numerator. So ratio is 2 raised 1. If the ratio is F12 by F13, then that is equal to 2. Question number 12. When the electron and proton both placed in electric field, then what happen? If they placed in electric field, then force will act on both charges. On electron, force is in the direction of electric field, and for proton the force is in the opposite direction of electric field. Sorry, the force on the electron is in the opposite direction of electric field and force on proton is in the direction of electric field. So the magnitude of force for both charges is equal to what? Q into E. Charge, both value of proton and electron, charge of proton and electron is same, so force is also same on both, but the direction is opposite. So what is the option? The electric force acting on them are equal in magnitude as well as direction. Wrong. On magnitude of forces are same, yes. Acceleration produced by them are same. If the force acting on charge is Q into E, then charge of electron and proton both are E. Force is equal to mass into acceleration, so acceleration produced in both charges EE by m. EE is same for both charges, so it is inversely proportional to m. Mass of proton is large than mass of electron, so acceleration is proton is greater than acceleration in electron. So the acceleration is not same for both. Magnitude of acceleration produced in them are same. No, wrong. So the answer is 2. Only magnitude of forces are same. Acceleration is also different and direction of force is also different for both the charges. Next question, if the force acting on a point charge Q placed in a uniform electric field is this much Newton, the value of charge Q is equal to 6.4 into 10 power minus 3 coulomb, and the force is equal to 0.128 Newton, then electric field is equal to F is equal to Q into E. So E is equal to F by Q. F 0.128, so 128 into 10 power minus 3, and Q 6.4, so 64 into 10 power minus 4. 64 2s are, so 2 into 10 power 1, so 20 Newton per coulomb is the answer. 14. The intensity of the electric field required to keep the water drop of radius this much just suspended in the air when electric charge with 1 electron is approximately. What is the intensity of electric field? To keep this drop stationary, you should apply a force equal to mg in upward direction. For that you are applying electric field, and this electric field you apply force QE in upward direction. When to keep this stationary, this QE must be becomes equal to mg. So electric field E is equal to mg by q. So what is the mass? Mass is not given, so we can consider mass is equal to density into volume. So what is the density of drop? Drop is of water, so density is 10 power 3. What is volume? Volume is equal to 4 by 3 pi r cube into g by cube. So 10 into 10 power 3 into 4 by 3 into pi is equal to 3.14 into r cube. What is the radius? 10 power minus 5 centimeter. So in meter 10 power minus 7 meter. So minus 7 into 3, 21 into g 9.8 divided by charge 1.6 into 10 power minus 19. So electron is present on that sphere, so that the charge is 1.6 into 10 power minus 19. So 4 into 3.14 into 9.8 divided by 3 divided by 1.6, so that is equal to 25.64. So approximately 26 into 10 power 19 minus 21 plus 3, so that is equal to 1. So 260 Newton per coulomb is the answer. Next question 15. On the axis of dipole, the angle between dipole moment and the electric field. On the axis of dipole, electric field is in the direction of p cap, so it is in the direction of dipole moment. So electric field also in the direction of dipole moment, so the angle between dipole moment and electric field is 0, both are in same direction. If they asked for point on the equatorial plane, then what happen? Then the electric field is in the direction of minus p cap, so the angle between p cap and minus p cap is 180 degree. Which of the following is not the characteristics of electric field lines? The field lines are continuous curve, that is correct. Two field lines never intersect each other, that is also correct. Field lines forms closed loop, this is not correct. Electric field lines never form closed loop, only magnetic field lines create closed loop, so C is incorrect. If the charge Q is placed at the center of the cube, then the flux associated with each edge. So let us revise the topic. Flux. Flux is what? The number of field lines passing through any surface is called what? Flux associated with that surface. So you can calculate the flux using two methods. First formula is E dot S, that is equal to ES cos theta. E is the electric field, S is the surface area, and theta is the angle between E and S. The surface area of every surface is normal to that surface always. And another method to find the flux is sigma q by epsilon naught, that is Gauss law. This method is only for the closed surface. The sigma q is the charge enclosed by the surface by epsilon naught, right? So first question, if the charge q is placed at the center of the cube, then the flux associated with each edge. Charge q is placed at the center, so the flux with whole cube and flux with each face is what? Though the flux with whole cube is the closed surface, so you can apply Gauss law. The charge enclosed by this cube is q, so flux associated with cube is q by epsilon naught. For each face, there are 6 faces, 1, 2, 3, 4, 5 and 6. So for each phase the flux is divided by 6, this divided by 6, so that is equal to q by 6 epsilon naught. If the charge is placed on the side of any cube, on any face of any cube, then what happen? To cover this charge you should place another cube here also. So the flux with this both cube will be q by epsilon naught, because the charge q is enclosed in these two cubes. So flux associated with one cube is divided by 2, and the flux with each face is divided by 6, so 6 to the 12 epsilon naught. If the charge is placed and the vertex of any cube, then the flux associated with one cube is q by 8 epsilon naught, and with one face is q by 6 into 8, 48 epsilon naught. You should remember this table. This is very important, because to cover this charge in a cube you should place 8 cube surrounding this charge, right? So when, if the charge q is placed at the center of the cube, then the flux associated with each edge is what? Q by 6 epsilon naught. Now how many edges are there? 1 2 3 4 5 6 7 8 9 10 11 12 edges are there. So with for whole cube the flux is q by epsilon naught. So for each edge flux is q by 12 epsilon naught. Whenever this type of surface is given, q is placed here, then you cannot apply Gauss law for this surface because this is not closed. So to make this surface closed, you should place same part here. You should double this part. Then what happen? The charge enclosed this in this whole cylinder is q. So the flux associated with whole cylinder is q by epsilon naught. Q by epsilon naught. But you are going to find the flux with only half cylinder. So you should divide this flux by 2. So whenever the closed surface is not given, you can make this surface close. Then find the flux with whole surface and with that given part. From that find this flux associated with the given part. 18 question. There exists an electric field 100 nanocoulomb Newton per coulomb in z direction. So electric field is 100 k cap, and the flux passing through the square of 10 centimeter side. So what is the area? 10 centimeter means 100 centimeter square. So 10 power minus 2 meter square. Placed in xy plane. When the surface is in xy plane, then its area is in z direction. So this is also k cap. Surface area S. Then the electric plate is inside the electric field. Then what happened? The flux through this surface is what? Flux is equal to E dot S, and K dot K is 1. So 100 into 10 power minus 2. So 10 power 2 into 10 power minus 2. So 1 Weber is the answer. 1 Newton meter square per coulomb. 19. The number of electric field lines emerge out from the 1 millicoulomb charge is. Number of field lines emerging out. Suppose this charge q is present. Many field lines are emerging out from this charge. Then consider a closed surface surrounded by surrounding to this charge. Then what happen? The total field lines, the emerging out field lines are passing through this surface. So you should calculate the flux associated with this surface. So flux associated with this surface is equal to what? Charge enclosed by surface by epsilon naught. Charge is equal to what? 1 millicoulomb. So 10 power minus 3. And epsilon naught is equal to what? 8.854 into 10 power minus 12. So this is the flux associated with this sphere, and flux is equal to what? The number of field lines passing through this sphere. So whatever the field lines emerging out from this charge, that is passing through this sphere. So flux associated with this sphere is also the number of field lines emerging out from this charge. So 1 divided by 8.854 is equal to 0.112 into 10 power 12 minus 3, 9. So 1.12 into 10 power 8 is the answer. So do practice for all these questions. Few other points are also here to cover in this chapter. The electric field due to the uniformly charged wire is equal to what? E is equal to lambda divided by 2 pi epsilon naught r. So electric field is inversely proportional to r, and it is in radial direction. So for positive charge it is in outward direction, and for negative charge it is in inward direction, right? And this r is the distance from this wire perpendicular to this axis. And another formula for electric field is for uniformly charged plane. For that plane the electric field is sigma by 2 epsilon naught. and direction of this electric field is normal to this surface. So this kind of a question sometimes asked in exam. Positive charge is distributed here and charge density is sigma. Negative charge is distributed here and charge density is minus sigma. And what is the electric field at this point and at this point? So for at this point the electric field is due to this surface, that is in outward direction, so going outward from this surface, that is equal to sigma by 2 epsilon naught. And for this surface there is negative charge, so electric field is in inward direction, so going inward in this charge, so that is equal to also sigma by 2 epsilon naught. Both electric field are in opposite direction, so resultant electric field is always 0. Okay. At the middle point the electric field is what? The electric field due to plus charge is outward direction, going outward from this charge, and for negative charge it is going inward to this charge. So both electric field are in same direction, so the resultant electric field is E plus E. So that is equal to sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So that is equal to sigma by epsilon naught. And remember, this electric field is independent of distance. You can calculate electric field here, 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 everywhere. Electric field due to this plane is same. It is depend only on surface charge density, nothing else, right? It is independent of distance. But this electric field due to uniformly long straight wire is depend on distance. So you should remember this concept for MCQ. This is most important concepts.